Hey everyone, welcome back to the official YouTube channel of WebOsmotic. Myself, Deshle, working as a full stack developer here at WebOsmotic Private Limited. And today we are diving deep into the world of Node.js socket servers using Socket.io and exploring how to scale them. Let's have a quick refresher on Node.js and Socket.io. Node.js is a powerful JavaScript runtime environment that excels in real-time applications, and Socket.io is a library on top of Node that allows bidirectional communication between server and client using technology known as WebSocket. Now, combining them both make them suitable for applications that requires real-time data exchange, like chat applications, gaming, and notifications. Now, let's consider a scenario of a chat application where user sends a message. The server needs to broadcast this message to all the connected users in real time. If the number of concurrent users are less, single server may be able to handle everything. But what will happen when your user base will explode? As the number of concurrent users will increase, the single server may get overwhelmed, resulting in lagging connections and frustrating user experience. And in worst case, server may get restart and resulting in downtime. So here where the scaling comes in. Through scaling, we can make our server highly available and improve its performance too. We can scale our socket server using adapter. Adapter is a server-side component which is used to broadcast events among the server instances. There are multiple adapters available in Node.js like Redis adapter, MongoDB adapter, cluster adapter, etc. I will be using and explaining Redis adapter here. So let's get our hands dirty with some code.
So here I have created a Node server. I have imported required libraries and we are using Redis. So I am using IO Redis package to create a Redis connection. I created an HTTP server, added IO Express server in it. Then here I am creating one socket server which will be used to accept our socket clients. Then using instrument library, I am connecting my server to the Socket.io admin UI, which I will be showing you in a while. Then I have created one GET API for sending message to these fake users. Then here comes the important part, which is about adapter. So I have created two Redis connections. One is a publisher client and one is a subscriber client. Now what is publisher and what is subscriber, I will be explaining you in a while. And using IO adapter method, I have attached Redis adapter to the socket server. And now this is our second script which I will be using to connect more than 3,000 to 4,000 fake users to our Node server, and we'll be sending message to them. So now let's start our Node server. I will be using PM2 over here to spawn two Node processes. Now what's PM2? PM2 stands for process manager, which is used to spawn multiple Node processes of a same server on a same port. You can find more details about PM2 on their official documentations. Here I have created one command, that is dev command, that will spawn two Node processes of our server. Let me run it. Here, as you can see, both of our server are listening on port 5000. Let me take you to the Socket.io admin UI. This UI is created in Vue.js technology. See, we have two socket server over here. Now let's run our test user script, which will connect 5000 fake users to our Node server. See, users are connecting with our Node server, and all 5000 users got connected to our server. Now we will be using our send message API to send message to these users. And API responses with 200. And see, all 5000 users got the message with having ID this. Now this API must have hit only one server, so that server can emit message to the socket connections connected to their server only. But how the users from other server got the same message? So here comes the Redis adapter. Now let's see what's happening behind the scenes. Before that, let me show you our Socket.io admin UI. See how beautifully the load balancer have distributed the traffic among these two servers. Now let's see what's happening behind the scenes.
Here I have drawn the basic architecture of our chat application, consisting of 4 different components. First one is users. These are basically our socket connections to the socket server. The second one is load balancers. Load balancers balances the loads and distribute the traffics amongst our socket server, so one socket server don't get overwhelmed. The third ones are our socket servers. These servers basically accept socket connections from our clients. Our clients are the users. And the fourth one and the important one is Redis. Redis is basically a database or a data store that lies in a memory which stores the data as a key value pair. And as it lies in a memory, its response time is very fast. That's why Redis is widely used for server-side caching, rate limiting APIs, notification systems, etc. Now, Redis provides us a concept of Redis channel. You can compare Redis channels with YouTube channel, where the content creator is a publisher and as a user, we are subscriber who subscribes to the channel and consumes the content. Now, let's say the user connected with the socket server number 2 sends a message, hi message to the server. Now, server 2 will receive the message hi, and server 2 can easily broadcast it to the user connected to itself only. But what about the users connected to the server 1 and server 2? So here, what adapters do? Adapters using the publisher client, as we saw in the code, publish the message in a Redis channel. And as other users have subscribed to Redis channels using those Redis subscribe client, they also receive the message from that channel and they also broadcast it to all the connected users that are connected to it. Thank you all for watching. Hope you find this video helpful. Now you must have better understanding of scaling Node.js socket server and role of Redis in it. If you have any question, feel free to ask in comment section. Don't forget to like, share and subscribe our YouTube channel for more tech videos like this. Until next time, happy coding.